Hello all, today we shall learn how to find the moment of inertia of a solid cylinder about an axis passing through its center and perpendicular to its length. Consider a solid cylinder and we have to find out the moment of inertia about its center. Let us say we have to write it as, we put it as AB and perpendicular to its length, say x prime x. We assume that the radius of the cylinder is r and mass is m. So what we have assumed, mass is m, length is small l, that is from here to here, and radius of the cylinder is r. We have to now have a knowledge, or we have to have a pre-information of the moment of inertia of a disc about its diameter. Diameter means about here, this way. That is equal to, as you all know, it is mass times radius square, the whole divided by 4. So let's put it as equation 1 for future reference. Now we can imagine the cylinder to be divided into a large number of circular discs. One circular disc I have shown here, the yellow one, with the plane at right angles to the length of the cylinder. So I can draw this way. Now we can calculate the mass per unit length of the cylinder. Mass per unit length, that is mass divided by length. So mass we have assumed as m and length we have assumed as L. Let's put it as rho. Okay, we'll give it an equation number 2. Now as I said before, I'll just draw the term perpendicular line also, AB, for which we have to calculate the moment of inertia. This is the x prime we had already mentioned earlier. Now certain things we have to decide for this yellow ring, yellow disc, that is, it is at a distance x away from the axis AB and it has a thickness, okay, dx. Therefore tell me what is the mass of the yellow disc. Mass of the yellow disc is equal to mass per unit length, yeah, correct, times the thickness dx. Now according to equation, so we will put it as equation 3, okay. Now according to equation 1, we have the moment of inertia of this disc about its diameter. You can see it's the diameter, okay. Diameter is equal to mass times radius square divided by 4. So mass we have found out as rho dx times radius. What is the radius? R square divided by 4. So this will give it an equation number 4. Again, using parallel axis theorem, we know that the moment of inertia about AB parallel to the diameter, this one, is equal to moment of inertia about the diameter plus mass into square of the distance between the axes, that is x. So that we can write it as moment of inertia about AB parallel to the diameter of the yellow disc, okay, the yellow disc is equal to moment of inertia about its diameter, which we have found in equation 4, plus what is it? Mass times square of the distance between the axes. Now you can tell me what is it. So it is equal to, as we found in equation 4, it is rho r square by 4 dx, then plus mass times, you know masses, we have found out in equation 3, this one, rho dx, and distance between the axes is, see here, it is x square. Okay. So we'll put this as equation number 5. Now we have to find out the total moment of inertia of the solid cylinder. That you can see that this power, the whole length of the cylinder is L. So from AB, you can, if this is 0 point, then you can say that it is L by 2. Okay, and this side is minus L by 2. So we have to integrate to get the moment of inertia of the whole of the solid cylinder. We have to integrate from minus L by 2 to plus L by 2. So we can write the total moment of inertia of the solid cylinder I as equal to integral minus L by 2 to plus L by 2. So rho r square by 4 dx. So I'll just put another color, plus integral minus L by 2 to plus L by 2 rho x square dx. Now we can see that rho r are constants including 4. Again here also rho is a constant, so you can take it outside the integral. Not only that, we can integrate from 0 to L by 2. This you can avoid and put it as equal to 0. Only thing you have to do is you have to multiply it by 2. So this equation becomes is equal to, so I am going to integrate from, tell me, it is from 0 to L by 2. Just put this. Plus. So what all I have to take it outside? The first term, rho r square by 4. So I have a 2 here because from minus L by 2 I have completed. So I have 2 here. Again I just put it first 2 here, and then I keep the row outside. Inside I have here only dx. Dx, and here I have x square dx. So this can be rewritten. So this gets cancelled, and I have 2 here. So you have this rho r square by 2 integral 0 to L by 2 plus 2 rho integral 0 to L by 2 x square dx. Here I forgot to put the dx. Okay. So the integral of dx is x, and integral of x square is x cube by 3. So I write it again, rho r square by 2 x plus 2 rho x cube by 3, and the limits are 0 to L by 2, 0 to L by 2. So we can rewrite this as equation rho r square by 2. So x becomes L by 2 plus 2 rho. You can take 3 outside, so it will be L cube by 8 inside. This is equal to rho r square by 4 L plus this I can get cancelled, so it becomes 12 rho L cube by 12. So my equation number I just forgot, so it is equation number 6. Therefore substituting for rho, okay, rho is nothing but m by L. So this becomes m r square by 4. You have an L down here and you have a L here. So I'll just r square by 4 L plus m by L into, that is L cube by 12. So this L and L here cancels. Here one L goes, and the result moment of inertia of a solid cylinder is m r square by 4 plus m L square by 12. So it's a very easy derivation. Just pick m outside. So what remains inside is r square by 4 plus L square by 12. So all of you should have understood this. Try to derive it yourself. Thank you.